Welcome to the video on first order reactions, and we're going to talk about how to calculate concentration change over time, specifically without you having to make a graph and use our graph calculator. A first order reaction is a reaction whose overall reaction order is 1. So we've just got one reactant making products, and so our rate law would just be rate time equals K times concentration of one reactant raised to the first power. So very simple reaction, and a lot of reactions like this. We already know that rate changes over time. It decreases as the reaction proceeds. And so if we were to plot time versus the concentration of our chemical versus A, we would see that the concentration of A is decreasing over time. We also know, you should hopefully know by now, that the rate of the reaction is the slope of the line. Well, we have a line which we can't find the slope because it's curved. So how do we find a straight line to give us a slope? For reasons that are steeped in calculus, and I will not even attempt to explain them, mostly because I don't understand them, if you really want to know, ask Coach Crocker. If we take the natural log of the concentration and plot that versus time, for a first order reaction, we will get a straight line, which is what we want. Again, slope equals rate. Now, in this case, slope is actually going to equal our rate constant. So we can use this graph to determine K. And then if we know K and we know the concentration, we can find the rate at any given time. Because remember, instantaneous rate is the tangent to the line, so the rate is going to change the whole time. So we can't get one line to give us our instantaneous rates. But if we can find the K, and we know the concentration, we can find the instantaneous rate at that concentration, whenever A reaches whatever concentration we want. So to calculate this, again, we don't want to have to use our graphing calculator, so we're going to have an equation. And the equation is the natural log of A at some time t minus the natural log of A at time 0, being our starting concentration, equals negative kt. And it's negative because you can see the line's going down with a negative slope. And since k is our slope, then it will be a negative slope of negative k. And to prove that, if we take the natural log, just rearrange this, kt equals negative kt plus natural log A0. This is y equals mx plus b, the equation for a line. So this is our y-intercept. Slope, starts here, and this is our slope. And then this is on our x-axis, and that is on our y-axis. So if you use this equation, you can find the concentration of any reactant at any time. So given a certain time, to find the right concentration, you have to know what the slope is. When we use this equation, 3 options. 1, let's say we want to find the concentration of a reactant at a specific time. So when t equals 10 seconds, how much of our reactant do we have? So we have to know how much reactant we started with, and we have to know what the slope of this line is. Or you could try to find the time required for a given fraction to react. For example, let's say that we want to do a half-life. How long does it take for half of this reactant to be reacted and turn into products? So we want to know how long to t will it take for this to be half of that. So if we started with 1 here, how long will it take for that to be half? We'll talk more about half-life. It's going to have its own video later, but that's just a basic introduction. Or the time required for the concentration to reach a certain level. For example, the question could say, how long will it take before the concentration of A is 0.02 moles, molarity, sorry. 0.02 molarity. So we could solve for T in that case. But again, we have to know K, and we get that from the slope. Key points from this slide. You need to know, 1, that if it's a first order reaction, the natural log of the reactant concentration will be a straight line. you can also use that to determine whether or not you're looking at a first order reaction. If you see a graph like this, where it's a straight line, time versus natural log, you have a first order reaction. And that's another kind of question that they can ask us. Looking at this graph, how can you tell if it's first order, second order, or whatever? That means that it's a first order. Alright, so watch the next video about second order.